why don't you take it away now? I think we basically agree on the facts that we got 14 and change down on the ground. Space dudes say that it drops to 10 to the minus 7, and then it keeps dropping out to 10 to the minus 17. You agree that it drops. And you agree that even in your version, right, your version that has a container, that the air pressure at the top of that container is superly low, right?
Yeah, superly.
Okay, and then we're at least tentatively agreeing that the way you calculate the force between two different pressures is you just subtract them.
Okay.
And that's the force per unit area. So like if we use PSI, pounds, which is force per square inch. So if you have a 1 square inch hole, that's super easy, right?
Mm-hmm.
Okay, so take it away. Show me how that means. How do we get to you can't have vacuum next to atmosphere?
Well, we kind of touched on it earlier about just the fact that there's air pressure here. There has to be a container because you can't have you just can't have that, man. Like it would. What's stopping the vacuum from just taking it all? Then, right? What stops it?
Okay,
Because this is where where I think we really
what stops it?
where we really differ here.
Okay, well, you said two things. First,
because you're saying
there has to be a container. Well, you just said that. Do you have a reason why there has to be a container, or is it what stops it is your reason?
Because the gas would just leave. Like there wouldn't be anything for us to breathe here. There wouldn't be any pressure for us to measure. The vacuum would just. You can't make a vacuum without a container, right? Like you can't even do that. Like all this stuff requires containers.
Who says?
I mean,
I don't know that.
Okay, hold on one sec. From what I was talking about, like to make a vacuum, like the Sandusky one, like like that's in a container, right? They didn't build it in an open field, right?
Right.
That's what I mean.
Okay, that's cool. But you agreed that up high, the pressure is superly low.
Yeah.
Okay, so we didn't need a container for that. Why would we need a container?
If you didn't have if you didn't have a container, you wouldn't even have any pressure though. Right?
What was this? So, what was the pressure you said was in space?
10 to the negative 17 or whatever.
Does that not qualify as superly low? As in, we agree on that.
That's like drastically lower than like what what's required for us to live and breathe and have air pressure, though.
Right. So down here, okay, we agreed we're breathing like 14 psi, right?
Right. So so then what's stopping the vacuum from taking our 14 psi? Like, where does it stop at? And
well, let me ask
you.
I
just have such a hard time conceptualizing a barrier with no barrier. Like when I hear that, I'm just like, huh?
Sure. I dig that. But let me ask you this in a different way.
Okay.
We got 14 psi down here.
Mm-hmm.
Up at the dome, up at the container, we have superly low pressure.
Mm-hmm.
How come our 14 psi didn't get sucked up into that superly low pressure?
I'm not sure, man. That's a good question. I should have known that.
That's going to be my answer for why we don't need a container.
All right.
Okay. Yeah. You want to think about it for a minute?
No, just tell me the answer real quick, and then we can talk about it then.
Well, I'd really like to hear what you think the answer is. What do you think I think the answer is? Let's say that.
All right. I think you think that it thins out or whatever, and then it just fades into nothing, and it's all chill. It's all good. Like it's all good. It all works out. I think that's what you think.
Sure. Yeah, but you think it fades out, and then instead of that being chill, it fades out, and then there's a container, right? That's the difference between us.
Yeah.
Like I think it fades out,
Well, you can have pressure
and we're
gradients
good.
in a
And then
like
you
in a
say
container,
it
right?
fades out, and then there's a container.
Yeah, because if there wasn't a container, there wouldn't be any fade out point. In my mind, how I'm seeing it, it would just take everything.
Okay. Um, Let me ask this:
Okay.
did it take everything?
I mean, that's
What's the
assuming
pressure?
that there's a
As
vacuum up
far,
there
far,
then.
far out as you can go. What did you say the pressure was?
10 to the negative 17.
Is that zero?
No.
So did it take everything?
No, but I feel like I mean, come on, man. Like that's so dude, I see what you're saying, but that's such a drastic change that there's just no way in my mind where there can't not be a container, man. Like I
Okay,
don't know
I'm
I
writing
don't know
this
the
down.
right I don't know the right way to convey it to you scientifically or whatever, but that's really where I struggle with that because it just doesn't make sense at all.
Okay, okay, such a drastic change. Can you quantify that? How
Yeah.
much change is too drastic? How much change is okay? It's not too drastic.
Okay, so we go from I guess like not would be too drastic would be, what we have here on Earth. And then as you would quote unquote go up to like where the ISS is at and all that kind of stuff, like when you get into the 10 to the negative 17 or, eights and nines and all that stuff, like these numbers are huge, man. And
Well, wait, how huge are they again? We did the math earlier.
we
How
didn't
huge are these
do,
numbers you're looking for?
well, did we do like, 10 of them to the negative 17 tour versus the PSI?
Okay, that's another common misconception. Let me ask about this.
Yeah.
10 to the negative 17 torr. How many psi is that?
Not sure. I'd have to get a converter out. Let me,
You want to get a converter out?
yeah, PSI to tour.
It looks like to me, one torr is 0.019336747 psi. So times 1 to the negative 17 equals that.
Oh yeah, that. Yeah. See a bunch of numbers, dude.
It's
Uh
a bunch of zeros. I don't know. It's just like a crap
yeah,
ton of zeros.
yeah, with all those numbers, dog,
Uh-huh.
it just seems like that's not even realistic that it would that it just fades out into that without succumbing to it.
Or can we
Or-
just call it close enough to zero that mathematically for our back of the envelope that we're doing tonight, can we just call it zero?
Sure.
Okay, we agree that it's not zero, but it's really, really small, like might as well be zero.
Sure. Yeah.
Okay, and then if going back to that problem we did earlier, how much difference is that between the depths of outer space and here on the ground? What was the pressure here on the ground again?
14.7 or I'm
Okay,
sorry, it was
let's ask what is the difference? I'm going to subtract
yeah.
14.7. There's the difference.
Dude, okay.
14.7
Yeah,
is the
yeah,
difference.
that. So
So 14 pounds is what we're sweating over. This drastic change that you cannot believe is 15 pounds.
yeah.
Can't believe 15 pounds. How many pounds do you believe?
Oh
We
no,
believe
oh no, no,
14
no. Oh
pounds?
no, no. I'm sorry. Yeah, no. That's what my argument is, but I don't know, man. It just doesn't seem like that's I
Is
can't really I
14
can't
pounds believable? Is
just
13 pounds? Where's the line?
hold on a sec, man.
Okay.
There's trying to think here. I don't know how to like, talk to you like with through math that way, It's like I feel like there's something that you're not I don't know, man. It just doesn't make sense to me the way it's portrayed and stuff and then versus oh it's actually only, less than minus nothing to the 14 psi. I just don't think that that's the case, man.
Okay. You don't think that it's really only 15 pounds? You think it'd be more
Yeah.
than that?
Yeah. I mean, right off the top of my head, I mean, I'll come back in the YouTube comments or something after I find some more stuff and we can talk about that. But yeah, I just don't think that that's a honest representation of what would happen
Okay.
if there was a vacuum up there that high.
Well,
Even though
why do
your
you
math
think
and all
that?
that checks out.
Can you tell me more? I mean, this is about the idea is
Okay.
you were gonna explain to me.
All
That's
right.
what I think.
All
I
right.
think pressure difference is a subtract. Difference
Okay.
means subtract.
So if it's barely nothing, why? Okay. So okay, just let's run through this process because this is how I'm understanding it.
Okay.
I was watching this video. It's an old video from like the ninth from like 1965 or something of an
Okay.
astronaut testing a spacesuit
Mhm.
in a vacuum chamber, and his suit fails, and he almost immediately dies. He passes out within like 1 or 2 seconds, and he says
Right.
the last thing he remembers was his tongue was the saliva on his tongue was boiling
Yeah.
and or was starting to boil. And
Mhm.
hold on one sec, lost my train of thought. Oh yeah, if it's only minus a fraction of that 14 psi, then why does he even need a spacesuit to begin with?
Well,
It doesn't make any sense.
because at 0 psi, water boils, right? And humans are
So
almost entirely made of water, so
no,
it's not cool.
no,
It's not cool for us. You ever had
I
a hickey? You ever got
no
a
no no
hickey or something similar?
no I get that, but so you're saying that they only uses that the only function of the spacesuit isn't to protect them from the air pressure of the vacuum, it's to
Oh,
protect
it
them
is.
from like the
It
from a
is.
from a
Humans don't explode in space like some of these movies we
no
see.
no 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 I'm not saying that, but I'm just saying like you would die. That's right.
Yeah, you would die.
Okay.
You go
So how
unconscious in like 30 seconds, and you're
so
gone in 90, I think.
yeah,
It
I well that guy passed out like pretty much instantly. If you
Yeah.
you seen the video?
Yes,
You know what
absolutely.
I'm talking about? Yeah. So
Yes.
that I mean that guy got clapped like, he was about to die. Like that was it for him. And that was like almost instantaneous. So I know that pressure difference that you're saying how it's only like a fraction of the 14.7 psi. I
Mhm.
know that there's something that I'm not getting that I don't know how to convey to you to explain that can't be right if that guy almost died immediately, right?
Well, I think the this what we're doing here is we're looking at it differently.
Mhm.
Um, 14.7 psi of negative pressure, negative gauge pressure, or essentially zero atmospheric pressure around you, will cause. That's not good for your body. That's not good. We can't survive that.
Right.
And I think you and I can
Well,
agree on that. We don't survive that.
let me
Someone was asking, how do you know you've been in space? No, I've never been in space, but people did study, particularly after the incident with the astronaut. Well, I mean, we all saw the video of the astronaut. He passed out, right? But he was okay. He
oh,
had bruising,
oh,
and his eyes were bloodshot, but he's okay. And then they studied it on animals. As bad as we all feel about animal testing, they did study it on animals to see
dude, I'll
how
put an
long
animal in a
animals
vacuum
survive.
right now. Just kidding.
Yeah,
I'm just
yeah. So we know, we know, or we have a good sense. We didn't do it with humans, uh, but we have a pretty good sense of what humans could probably survive. And to their credit, Guardians of the Galaxy got it right. Right when Star Lord goes out in space and he like turns off his spacesuit and he doesn't explode, he freezes and bruises and passes out almost immediately. Yeah, that's what happens.
I mean, according to the movie.
Yeah, no, they didn't have him explode like some of the movies do. So
Dude,
I'm just giving them props. That's
if they
all.
did if they didn't repressurize that container and help that dude, he'd have been dead within like a minute or two, dude, because he
Uh-huh.
was boiling, right?
Yeah,
Like
that's
that's a
right.
wrap. You don't just come back from that.
That's
So
right.
so Star Lord's dead,
Well, they got him within like 30 seconds. Where they got him right away. Is the idea, right?
yeah, yeah. And I got you. I'm just
It's movie.
yeah, yeah. So let me ask you this, man. I think we talked about this before, the Chris Hadfield thing with the hole in the ISS, and he
Yeah, yeah.
yeah. So how were they not all dead like immediately? Because they don't
Because it's not that big
they,
a deal.
but your boy almost died in 65 over it. Like, so how is it not that big a deal? They're in a
Okay.
stronger vacuum, right?
When you
This is
open a
where
soda,
yeah.
right? You open a soda. Does all the pressure come out of the soda instantly, or does it kind of hiss as it leaks out?
I mean, it okay, yeah, fair point.
Okay, and
If you crack it
go to your
open a little bit.
tire, right, and you put your finger on the valve for the tire, does it just go flat, or does it go?
Well, what happens if you poke a hole in your tire though?
It slowly leaks out, unless your tire pops, right? If your tire blows, then it all comes out. But if you just let it out of a small hole, you can have a slow leak in your tire and drive for days and not notice, right?
Yeah, fair point.
Okay, so how big was that hole in the ISS?
I don't remember off the top of my head.
It was a nail, about the size of a nail. It was like, I don't know, we could look it up, but it wasn't big.
Yeah. Well, how big was the hole in that dude's spacesuit when it failed?
It was the valve. It was his feeder line. It wasn't actually his suit. His suit was fine. He was connected to an umbilical.
Oh, right.
He
So
didn't have his own oxygen source. He was connected
yeah.
to a cable, and that thing ruptured. So it was pretty big. So it deflated pretty fast.
Okay, fair enough.
Yeah, but the ISS, I mean, people live in it, right? So it's pretty big.
Allegedly.
Oh, allegedly. People allegedly live in it, right?
Yeah.
So it's got to be pretty big. And you put a little hole in it, it's going to leak like your tire leaks. And they also have things that continually pump new air in for them, right? They have compressed air that feeds them. So as long as the compressed air can outdo the little hole, it won't do anything.
Yeah, I hear what you're saying, man, but fuck, that's a lot to take in. I'm gonna have to process that because it still just doesn't seem right, man. It seems like that's a lot for me to go over on. So I appreciate what you're saying though. I got
Okay.
you. You're making some decent points here.
All right. Well, let's go back to, do we need a container? What is the purpose of the container in your model? What does it do that we couldn't live without? What does it do?
Well, it provides the pressure that we experience. It allows us to have that 14.7 to live here.
Because without it, the superly low pressure that's at the top would blow away.
No,
No.
okay, so let's look at it like this. Let's say the ISS, right? Let's just say, they just cut that bad boy in half and it was only the bottom half that they lived under and the other half was just open to the vacuum of space. That's what, like, would there be any air pressure on the floor of the ISS? Like, no, of course not, right?
It'd be sucked out right fast.
Right. So why would there be pressure on Earth if there was a vacuum like that on the surface?
Well, okay.
Right?
In the ISS, what's the atmospheric pressure in the ISS?
I don't know, the 14.7, whatever they make it so that they can
Let's
survive,
say
right?
14. Yeah. Okay. So 14 compared to 0 is 14 pounds for every square inch, right? So if you cut a big gaping hole, boom, out comes the pressure all through the hole, right?
No, I'm saying just remove the whole top, like cut it in half, like, horizontally, like so you're just taking the roof off. Like there's no hole. There's no hole. There's
big
just
gaping hole, right?
yeah.
The whole bottom is a hole now.
Yeah, well, the whole top and then the bottom.
Okay, whole top.
Yeah. The bottom we're saying would be like the 14.7 on Earth, like comparatively, or
Right.
whatever. You know what I'm trying to say, right?
Yeah. I mean, all that air would get sucked out because there's a difference. Outside is 0, inside is 14. So the air flows from the 14 to the 0.
Right. So why doesn't it do that on
Earth? The bigger
then?
the hole, the faster the flow. Can we agree on that?
Yep. Sure.
Okay. So if you make a massive hole, okay, Astro says it's 12 psi. Okay, cool. Thanks, Astro. So 12 to 0, it's going to go out very, very rapidly, essentially instantly, right?
Yeah.
Okay. In your model, there is superly low pressure
Just call it
at
low.
at
I
the
feel like
dome.
I kind of feel like you're taking a dig at me with the super
No, I'm
late.
sorry. I don't mean no. I mean
Oh, we're
okay.
good.
Yeah, it sounds like a dig. Let's just call it low.
Yeah.
Low pressure. There's low pressure at the dome, and there's 14 pounds at the ground.
Yeah.
And the 14 pounds at the ground is not rushing straight up to the top of the dome.
Gotcha.
Okay, so you're going to need to explain that.
Okay. You write that down. That'll be a further note for later. What was your question again? Say it again. I'm gonna.
Okay, what keeps our 14 pounds here, 14 psi, from just rushing and getting sucked up to the top of the dome where we have low pressure? There's low pressure at the top of the dome there, and there's 14 psi down here. How come it just doesn't get sucked up?
Okay. Not sure, but I'm sure there is an answer to that. I just don't know it off the top of my head. I'll have to get
Okay.
back to you on that. But let's
Okay,
let's
but
let's say
okay.
hypothetically though
Mhm.
that there's like some reason, whatever. Let's just say that there is a
Okay.
reason.
Okay.
Uh,
Let's call it I don't know, suckitude. I don't know. Right? I don't know.
n-
Make up a
no, we
word.
don't. No, we don't have to do anything like that. I I feel like it's just. Uh, I don't know how to. I don't know how to say it, man. Let's see. Yeah, I can't think of how to convey what I'm thinking in my head here.
Okay. Well, what I'm thinking
Yeah.
is that whatever answer you've got, and I'm going to deliberately make up a silly answer. I'm not trying to make fun of you. I'm just
No,
making
you're
up
good. You're
something
good.
we can agree is totally not true. Okay.
Okay. Yeah.
Right. So we agree it is not because of unicorn farts. Right. It's unicorn farts.
Well, we can't rule
Unicorn
that out, but
farts is what
just kidding.
keeps the air at the ground from getting sucked up to the dome.
Yeah.
Okay. And as soon as you tell me that, I'm going to say unicorn farts is what keeps the air from getting sucked out into space. And I don't need a dome.
Hmm.
So, unless it is the dome itself that is somehow preventing the air getting to the dome, then your dome has no logical purpose.
Yeah. Got you, dude. I'll have to get back to you on that, man. I know there's an answer to it, but I can't remember off the top of my head.
Okay.
And that's my fault for not being super prepared on
Well,
that.
that's all right.
I should have had an answer for that. I've heard it explained, but I can't even remember, and then I'm nervous too. So uh,
Okay. That's cool.
anyway,
Let me ask you to think of it a different way.
okay.
What do you think I think it is?
I think I remember you linking a video, or somebody linked a video on your vacuum video actually, and it was like some dude was saying that the particles spread out or something like that, and uh, and it just kind of fades into nothing. Is from what I remember. Could be
Yeah.
remembering that wrong. He has like a model of it. You know what I'm talking about? The guy that somebody linked a video to another video on your
Yeah.
videos. But
Probably
anyway,
like a simulation, was it?
yeah. And it was
Nick
like a
West has a really nice gas
simulation of.
simulation, particle simulation thing.
Yeah, it sounds like something like that. So that's what I think you think, that it kind of just fades out to where it's not relative or something, you know?
I've got one more though. I mean, I got a reason why.
Okay.
Why is the pressure greater down here than it is up there?
I don't know.
What you don't know why I think that?
No.
Okay, then before I give you the answer,
Uh-huh.
um, how long have you researched this?
Dude, probably like 3 or 4 hours. 'Cause
Okay,
I've seen a bunch of rhetoric on it, you know? So I feel like that was the way to go. And then,
right.
so like I said, man, we're not here to debate or anything. Like
No, no,
I'm
not at
here to
all.
see what you guys are, what this shit's all about, because,
Okay.
you know,
That's totally fair.
sometimes you don't think about the shit, and you just, you've heard it so many times. You're like, yeah, man, what the fuck's up with that? So
Is it fair then to say that in your 3 or 4 hours of research, you only looked at the flat Earth research and you did not look at all at the science stuff?
God damn it, you're right. I did do that. Son of a bitch. I did do that. You're absolutely right. Fair enough. Very good
Right.
call. I did.
And so I think we have a major revelation there because yeah, we all do that. We all do.
Yeah.
I don't watch flat Earth videos. I
Yeah.
can't stand them. Right. So I will only watch like the debunker videos. Right. And I think that's true. I think
Dude,
you probably
that's
only watch.
crazy because I can't stand those because most of the debunker
Exactly.
people, they've got such an attitude about it where they're like, "You
Of course.
stupid fucking flat Earth," like they just go on this tirade, and it's like, "Oh,
And
buddy, you
vice
don't."
versa.
Yeah,
And
true,
vice
true,
versa.
true,
Right.
and yeah, and I try and stay away from that side of it too.